Hi guys, this is Mr. Krieger and this is Algebra 1. We're going to be doing Lesson 2, and the first page of Lesson 2 looks like this. But we're going to do this page and a few other pages in class. We're going to be starting on question number 7, which I think is the third page into the lesson. It's some word problems. And we're just going to, in class we've done a few of these word problems, and I just thought we would do a few more word problems just to make sure you're good and comfortable with them. So if you're having a hard time reading this on the video, make sure you take a look at a copy of the lesson so you can see the problem a little bit better. I'll read it out loud though, so you can so you at least know what it says. Alice charges $5.50 an hour to babysit, plus $3 for gas if she drives to the person's house. If Alice made $30.50 for one night of babysitting, and she drove to the house, how many hours did she babysit? So one thing that you should consider is defining the variable that's missing. Well, what we're missing is how many hours she worked or how many hours she babysat. So what we want to do is we're going to let x equals number of hours, let's say working. Okay, so that's going to be our variable. What we know is she makes $5.50 each hour. X is the number of hours she works, so we want to multiply 550 by X. She's going to charge an extra $3 for gas. Excuse me. She's going to charge an extra $3 for gas, and this total is going to be $30.50. Once you've written your equation, then the solution is pretty easy because we know how to solve basic linear equations like this with one variable, or basic equations in one variable. You subtract 3 from both sides. You get 550x equals 2750. Divide by 550. And when you divide it, you're going to get x equals 5 hours. X equals 5. So the number of hours that Alice worked is 5 hours, okay? So let's maybe you can try the next problem on your own. Pause the video, try it out. I'll do the problem though. The cost of a long distance phone call is 56 cents for the first minute and 32 cents for each additional minute. What's the total length of a call that costs $9.20? Well, x is the number of minutes. This is the variable. So we'll let x be the number of minutes beyond 1 minute. So basically, x is gonna be, let's say the person put a call in that was 20 minutes. The first minute they got for 56 cents, and it was the 19 minutes that they got for 32 cents each. So x is not going to be the total amount of minutes. We're still going to have to add on that extra minute. But let's find out what x is. So we're going to make our equation, which is going to be 0.32 cents per minute times x minutes plus 0.56. That's not going to be times by anything because that's only for the first minute. It's only once. And this call is going to cost $9.20. Now this is just a number and that's just a number. So we can subtract off 0.56 on both sides. So this is going to cancel out, and that's going to become $8 and I believe it's 74, but I'm going to double check on my calculator. So we're going to do 920, and we're going to subtract off 0.56, and we get, well, 864, you see, calculators are good. 864, and we're going to get 0.32x on this side. You know, you divide by 0.32 on both sides. Let's see what that becomes. 8.64 divided by 0.32 gets us 27. So x is 27 minutes. Now that's the number of minutes beyond the first minute. That doesn't include the first minute. So the total number of minutes is the x plus that first minute. So we really have a 28-minute phone call. Okay? Let's take a look at the next problem. This is a different kind of problem. This is going to be a proportion. Let's see how. It is said that 4 out of every 50 people are left-handed. if there are about 800 students in WMS, Woodmere Middle School, how many of them would be left-handed? Write a proportion and solve, okay? So let's take a look. We know that there are 4 left-handed people out of 50 people, but we know that there are 800 people in the school. So this is total number of people. This is total. And the numerator is the left-handed people. So 4 left-handed people per 50 people. Okay, here we don't know how many left-handed people in the school there are, but we do know that there are 800 people in the school. So that's the total number of middle school students. And we're trying to find the number of left-handed students. Notice that that matches up with the 4. Because 4, the top represented left-handed people, the bottom represents total people. So if there's 50 total people, there are 4 left-handers. If there are 800 total people, then there should be a corresponding number of left-handers corresponding to like that number. Now we cross multiply. I'm just going to do this with a thinner pen so I don't write over everything. We're going to cross multiply this way because it's a proportion. So you get 50 times x is 50x. And 4 times 800 is 3,200. And we divide both sides by 50. And you're going to get x equals 64. So in the school of 800 students, you should expect about 64. Well, since this is exact stuff, there would be 64 left-handed students. Okay? Now you could try the next one. It's also a proportion problem. Think it through. The C's shop sells rocks that come in a variety of packages. The cost per rock in each package is the same. So each rock costs the same amount. A package of 12 rocks costs 72. How much would a package of 17 rocks cost? Well, we could do it this way. We could say, well, 12 rocks cost 72 cents. So 12 rocks goes with 72 cents. We're going to do 17 rocks goes with how many cents or how much money? This is the proportion. Remember, on the top, we have number of rocks. And the bottom, we have the cost of that number of rocks. Okay? Total number of rocks, cost. Total number of rocks, cost. They're going to be related to each other in that fashion. Now we could just cross multiply this. So we're going to get 12x equals 17 times 72 is 1224. Divide both sides by 12. And we get that the package costs $1.02 or 102 cents. Okay? All right. So that was some practice with word problems. I know word problems are difficult for a lot of people, but I want you to have at least a video to go over showing you how to do these types of problems. We'll have done some live as well. Now we're going to just do one other thing today. We're going to talk about literal equations. So a literal equation, the word literal or literate has to do with letters. So literal is literally letter. Notice this equation has multiple letters, J and K. And it has a number. It says J, I'll write it a little larger, J equals 12K. Now when they want you to solve a literal equation, it's asking you to get one of the variables by itself. Now right now J is by itself, but it wants you to get K by itself. So it's telling you to solve for K. So right now J is by itself, but K has a 12 next to it. Well, how would we get 12 away from the K? We can't just erase it. What we're going to do is we're going to divide it. So 12 divided by 12 is 1, so we just got the K by itself. And this side we got J over 12. We got K by itself by dividing by 12. You're going to use the same exact algebraic techniques you use for regular equations for these literal equations. You're just trying to get a specific variable by itself. Let's take a look at the next one. Y plus 2x equals -1. We want to get y by itself. Let me write this a little bit larger. This one's pretty easy. I want to get y by itself, so I'm going to have to subtract 2x on both sides. You're probably familiar with what happens here. This is y equals, those cancel out, and these are not like terms. Put the x term first, it's actually -2x minus 1, and you've gotten the y by itself. You've solved for y. Okay, this equation, you have 3 variables, d equals rt. Think if you can, what these letters might stand for. They stand for distance is equal to rate times time. In other words, suppose we're going 60 miles an hour. That would be our rate. Suppose we're going for 2 hours. That would be time. Well, if we're doing 60 miles an hour for 2 hours, that means our total distance would be 60 times 2, 120 miles. Now, what they want us to do here, excuse me, they want us to get t by itself. So right now the r is next to the t. How can I get rid of the r? I just can't cross it out. I just can't erase it, but I can divide it. And when I divide it, the r divided by r becomes 1. The r's essentially cancel out because they divide it out, and we get dt equals d over r. So we've gotten t by itself. Here's something very similar. V equals L times W times H. What do you think those letters stand for? You might know an equation that looks like that. So volume is equal to length times width times height for a rectangular prism. We want to get L by itself. Let me write this a little larger. L times W times H. Well, I don't want the W and H here, so we're going to divide both sides by WH. And you're going to get L equals V divided by WH. Now, let's see something. Now you got L by itself. All right, let's try this one. We want to get Y by itself. We have a 2y and a negative 4x. First thing you should do is you should isolate the variable you want by adding or subtracting anything that's on the same side of the equation with the variable in question, with the y. So let's add 4x to both sides, and you're going to get 2y equals 4x plus 10. Those are not like terms, so you couldn't combine them. But we still don't have y by itself because there's a 2 in front of it, but you're going to divide everything by 2. I literally like just to divide every term by 2, and we wind up getting y equals 2x plus 5. Okay? Here's an interesting one because this one has a fraction in it. And as I told you before, it's not so difficult to work with fractions, especially if you have a graphing calculator. But we want to get b by itself. Let me write this a little larger. We have a equals 1/2 bh. Well, one way I can get rid of, I want the b by itself, so I don't want the h there or the half. Let me deal with the half first. It's a numerical value. It's a fraction. I'm going to want to do the reciprocal of that on both sides, which is basically 2. 1/2 times 2 is just 1, so that's going to cancel out. You're going to get 2a on this side equals bh. So at least you got the number away. But you still have, you want the b by itself, and there's still an h there. Well, divide by h. The h's will divide out. You're going to have b by itself. I'll rewrite it over here. b equals 2a over h. Okay? Let's do one more of these, and hopefully you'll get the hang of it. In this problem, we want to get w by itself. Let's see what this actually means. Do you have any idea what these letters stand for? P equals 2l plus 2w. This is the formula for the perimeter of a rectangle. A rectangle's perimeter is double the length plus double the width. We want to get the width by itself. Let me rewrite this a little bit larger. Well, the 2w, well, there's a 2 there, but I have to deal with the things that are multiplied together last. I have to get rid of whatever's added to it. There's a 2l added to 2w. I don't want the 2l there. I'm going to have to subtract the 2l from both sides, and there's going to be a 2w on this side. This is gone. And these are not like terms, so I'm just going to get p minus 2l. All right, I'm getting closer. I have 2w, so w is not quite by itself on this side. It has a 2 there, but at least it doesn't have any l's on this side of the equation. Now I need to get rid of that 2. This is a multiplication, so the opposite of multiplication is division. I divide by 2, and we're going to get w equals p minus 2l over 2. You could leave it like that. That's fine. So width is equal to perimeter minus 2 times the length, all divided by 2. So that would show you what the width of this rectangle is. I'll let you try the last one on your own. Actually, I'll just quickly do the answer for you, so this way you got it. So we want y by itself. It's actually a good one because of one thing. Some people might not like to deal with this negative y, so they might want to add y to both sides. But you might not realize that first. So I'm going to subtract 2x from both sides because I don't want the x's with my y, because I want y by itself. So I'm going to get negative y. Remember, this negative had nothing to do with this. So that's still negative y, and this can't be combined, so you're going to get negative 2x plus 6. Now what I need to do is I don't want that negative there, but what is it really? It's a negative 1. Divide everything by negative 1. Negative divided by a negative is a positive, so that's just going to become positive y. A negative divided by a negative is positive, so that's going to be 2x. And 6 divided by negative 1 is negative 6. And we have now gotten y by itself. Okay, so hopefully you understand now how to operate with literal equations, rearranging the terms so that you can get the specific variable that you want isolated. Okay? Okay, so you work on your homework.